Sir, within a 5 minutes, I will be start the session, sir. Sir, my voice is audible. Sir, my voice is audible. My voice is audible.
Yes, sir.
Okay, okay, ma'am. Thank you. सर, आपको मेरी आवाज सुनाई दे रही है? अरविंद सर?
जी सर, आ रही है आपकी आवाज।
ओके। नहीं, एक्चुअली सर को आवाज नहीं जा रही है, लगता है।
Hello.
Hello.
Yes, sir. Audible, sir?
Yes, audible, sir. You are audible.
Yes.
Now your voice is very clear.
Yes, sir.
Within a 5 minutes, I will be start the session, sir.
Okay, sir. No problem. एक लेक्चर है लेक्चर है ओके सर थैंक यू वेरी मच सर
Now I will start the session. Ladies and gentlemen, good afternoon. On behalf of Professor Ramkrishna More, Arts, Commerce and Science College, it is my great pleasure to extend warm welcome to each one of you join for the 10 days National Online Capacity Building Program on research methodology and the magic of statistics. Again, I welcome to Dr. Arvind Biradar sir for taking a wonderful session. Now I hand over to my Dr. Biradar sir. Please start the session and guidance our participants, sir. Session will be start.
okay thank you very much sir good afternoon to everyone audible sir
Good afternoon, sir.
very good afternoon
So you are audible, sir.
Yesterday you discussed a lot of things related to the basic of SPSS, the particularly data view, variable view, and how to enter it, how to create the new variables, sorting the files, splitting the files, and some label descriptive statistics. While analyzing data, what type of problems are arising? For demonstrations, we are using the small quantity variables. Small quantity data is there. But if you consider analysis of questionnaires, there are n number of questions are there. The first of all, we must coding the data. How to coding the data? It is an art. If you code properly, you can understand the data properly as well as analysis in a better way. Now I shared the one questionnaire with you. So that questionnaire is just 1 minute. My screen is visible.
Yes, sir. Your screen is visible, sir.
Visible.
Yes, sir.
Ah, sir.
Okay. Just 1 minute, sir.
Yes, sir. No problem, sir.
See that this is the one questionnaire. The questionnaire is related to eating out habits of individual. It is a research paper. The near about 76 the participant in this sample survey and contain the questions. Suppose now I want to analyze this data. How to define the variable? So already you know that the variable must start with the letters, with the specific characters. Space is not allowed. Labeling is also important. But if you consider the question number 1, how many times do you eat out in a week? 1 to 3, 4 to 6, 7 to 9, 10 to 12, 13 to 15, like that. So the 76th participant, the answer in the different ways. One may be the 1 to 3, one may be the 7 to 9 times, like that. Under these conditions, I'm going to put the first question is marked as a x1. The variable name is x1, not 1x. 1 x. 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 numeric number should not be accepted as a beginning letter. Okay. So the first variable is x1. In that one, 1, 2, 3, if anyone is saying that one, it is a 1. It is a value of this. Number 1, the range is 1 to 3. Number 2, range is 4 to 6. Number 3, range is 7 to 9. Yesterday you put 0 for male, 1 for female. Like that, you can define variable values in the x1 variable. I hope this question is clear. Okay. And the second thing is that on the same line, question number 2, which of the following categories of eaters do you visit the most? So I define this entire question is x2 variable. x2 variable. Again, in that x2 variable, there are various options are there. Option number 1, restaurant, fast food, food court, dhaba, home delivery. You can mention the label value, 1 for restaurant, 2 for fast food, like that. So here is on the same line x3, these variables. Okay, this is. So the question number 5 is comes. For what reason do you eat out? There are 5 questions are there. 1, 2, 3, 4, 5. So my question serial is a x5. I divide. This first option is A, that is x5a. That is 0 for no, 1 for yes. Similarly for x5b, again 0 and 1. 0 and 1 means what? No and yes. Okay. So in this way, you have to define variable in a database. x5, x6, here is x7, this is x7, this is x7a, x7b, see that, x7d, like this. Okay. So again, here is question is come, same thing is that. Here is also, how do you rate the following when you decided to eat out? This is the question number 9. The sub questions A to O. So this is 1, 2, 3, 4, 5, 6, 7, 8, or A, B, C, D, like that. Okay, A, B, C, D, E, F. Okay, E, F, G, H, I. Okay, J. Okay, in this way you have to define. Say for example, question number 9. Some participant mentioned that this is a 3. 3 means what? The taste of food, neither important nor unimportant. Okay. So the labels are automatically computerized displayed during the output. Okay. Again, same thing is that age is a question number is variable number is 10, x10. So these are the sub questions. So sub questions mentioned 1, 2, 3, 4, like that. So this is 11, 12, 13, 14, like that. So is it clear, all of you? Any doubt in this case, coding? May I audible or no? Okay.
Yes, sir, you are audible, sir.
Yeah. Any questions regarding the variable type, variable names? So if you define any questionnaires in this fashion, it is very easy to analysis, easy to apply. Various statistical tools depends upon hypothesis. Otherwise, it creates a lot of confusion in our mind during the analysis. Okay, so it is one of the easiest, simplest way. First, code it in Excel sheet. From the Excel sheet, we can import to SPSS. Okay. Any questions on that Excel? Anybody?
No, sir.
Sir,
Now,
please can
yeah.
you show this again? This last step.
Last one. Just 1 minute. One minute. Last question.
Yes, yes, sir.
Okay. Do you own your vehicle? Is it one? This one?
Yes, got it, sir.
Got it. So, one thing is that how many questions in our questionnaire is? You, start from the x1, x2, x3, so on. If any sub questions are there, one can use A, B, C, D. If options are categorical, one can use yes or no, 0 or 1, like that. Okay. So I hope everyone is expert how to prepare the questionnaires. Your questionnaire is directly related to the hypothesis. You can consider your questionnaires and your objectives of your thesis and define the hypothesis. What are independent variables? What are the dependent variables? How these two are correlated? What you are going to estimate? All these things you must take into consideration during analysis. So see that here is 20 to 30, 31 to 40, 41 to 50, 51 to 60. Is it correct? What type of class is this one?
Discrete.
Not a discrete, this is a continuous, but it is a inclusive, exclusive method. Exclusive.
Okay.
So here is no continuation. 20 to 30, break. 31 to 40, again break. So this value is contains of 20 to 30. And this value is contained 31 to 40. So you want to prepare 20 to 30, 30 to 40, 40 to 50, 50 to 60, like that. So this kind of the classes are very useful in further statistical analysis. Okay. And okay, some are demographic parameters are there, rest of things are same. Okay. Now, so everyone having this data, this file, height, weight, and gender.
Yes, sir.
Yes,
Okay.
sir.
So I consider three variables. The one is the gender, second is the weight, and the third one is the height. We can apply the measures of central tendency. That means mean, median, mode, and all these things. Yesterday I told about the descriptive statistics. And also we can apply measures of dispersion. In that measures of dispersion, mean, median, mean is the standard deviation, variance, these two, range, minimum, maximum. So all these are related to the measures of dispersion. Now, the two variables are there. Height is 65, 52, 77. Suppose my height is 80. What would be the weight of 80 kg? 80 pound. This is a pound, is that? In inches are there. How to calculate that one? Anybody? Suppose I want to calculate weight by knowing the height is 80. Yes. So here is estimation is there. I want to estimate unknown variables with known. In this case, we are using linear regression. Linear regression. In this linear regression, the simple linear regression equation is y equal to a plus bx. I hope everyone knows this one. Y equal to a plus bx. A and b are constant. Okay. So we want to calculate y is equal to a plus b, bx. A and b are constant. Y is dependent variable. X is the independent variable. If we know the
Sir, can you show that? I mean, what you are saying, can you write it on the screen?
this is my difficulties. Just 1 minute. I will show that. See that. So y equal to a plus bx. Okay. Y is equal to a plus bx. A is a constant, b is constant. X is independent variable. By knowing this value, we can easily estimate the value of y. This is linear regression. So there is a lot of mathematics is there, formula is there, estimating A and B. I'm not going to interested to say about all these things. Okay. So that's almost all everyone knows that A is equal to summation of y upon n, B is equal to summation of x squared divided by x. X is there. This is single variable is that. So here is so linear regression. Regression. Okay. How to calculate linear regression? Analyze regression. Okay. Linear regression. Linear regressions. Is it clear? So height, weight. Here dependent variables. I'm going to take it. Weight. Independent is height. Okay. Don't see anything about it.
Sir, one small doubt.
Well,
Sir, on
yes,
my panel, on analyze, I cannot find linear regression. Is it in some other way? Other?
analyze. Here is there, madam. Regression.
Okay. Sorry, sir. Thank you so much.
Regression. Here is a linear. Okay. Yes. That's good. See that. This is the output. Model of the something. R square, then adjusted R, this standard error estimate, this one. So this standard error of estimate gives you a measure of dispersion for your prediction equations. When the prediction equation is used about how many percentage? R square is 19% is there. Okay. Of the data that will fall within one standard error of estimate per minute. Okay, see that the interpretation of standard error estimate here is the 34, that means the 34%. See that how to interpret these values. The standard error of estimate gives you the methods of dispersion for your prediction equation. When prediction equation is used, 34% of the data will fall within one standard error of estimate predicted value for 95%. Here is 95% level of significance. I used that one. Okay. Just 1 minute.
Sir, your voice is not audible.
Yeah. Now it is okay. Just 1 minute. I'm going to see that any other results in that one.
Yes, now it is audible.
Yeah. Coefficient is that. Coefficient, height coefficient is this much is there. Okay. 0.2 is there. That is 0.6 for standard error. Okay. And this one, standardized coefficient is a 0.86. Standardized 0.136. Okay. P value is this significant 0.70. So the value is not a significant. This value is more than 0.05. Dependent variable is weight. So so 1 minute, just we are going to take into consideration of standard error. See that. So how we are going to interpret these values? I told that y is equal to a plus bx is there. Okay. X is an independent variable, y is a dependent variable. Now I want to find out the value of a and b. So here, here, this is the value of a, the constant 1.54.175, and that b value is 0.250. Okay. Yes. And x value, just 1 minute. 1 minute. 154 8 plus 0.50 80. Look here, this a and b, See that. I want to estimate the value of weight. My equation is the y is equal to 80 is there, right? Look here. So the place weight equal to a value is 150 point. So I consider a round figure 154 plus p value is a 0.50 and height is 80. So what will be the answer of this one? Anybody's? What are these? The 0.250. So this is a 0.250, don't 250. This is a point. The 0.250 into 80 plus 154. So it comes 174. Is it right? Anyone? Anybody?
Yes, sir.
So
Yes, sir.
my point is that the height is 80. The estimated the weight of this one is 174. Is it okay? See, once again, I want to show that. Analyze, regression, linear, weight, height. Okay. This. The values comes coefficient values. Consider this also. Therefore, the values are different. So, constant of A, this is a constant of B.
So
If you
please
con-
explain.
Hello.
So please explain the significance value also that is given.
So,
हेलो
so here is I estimated.
सर इसमें एफ वैल्यू जो है वो नॉट सिग्निफिकेंट दिख रही है उसका कुछ होगा इससे रिलेटेड
See, that concept is different, significant. Here is I'm not going to consider this value. My point is what? Suppose here is, if you see that, my equation for linear is y is equal to a plus bx. Okay. By knowing the value of x, I want to estimate value of y. So there is a lot of procedure is there for calculating a and b constant. In a linear regression by using SPSS, I got the value of a and b. The value of a is 154 and the value of b is 1.54. When the height is 80, the weight is 174. This is estimated value. Suppose here, now tell me, what is the relationship between height and weight? In multiple, anybody? What is the
Sir, one
relationship
small
between?
question. The A and B that you have taken is from the coefficients in the SPPS?
Yes.
SPSS? Okay,
Yes.
thank you.
So, Just 1 minute. Correlation is there. Just I want to say that correlations. Analyze correlations. There are 3 types of the correlations. The one is the bivariate correlation, and second one is the partial correlation, distance canonical correlation. I go for bivariate. Okay. Option is
हेलो
see that
सर
height
यहाँ
and
पे
weight.
जो कोरिलेशन है वो सिग्निफिकेंट नहीं है, तो क्या हम इस पे रिग्रेशन
So
रन कर सकते हैं?
see, the height and weight is highly correlated. 0.9, 0.9, highly correlated. So the whatever I estimated the value 174 is more accurate. Suppose if you want to see the significant and all these things, I'm going to take one more test. Is that one the student T test? There you can understand how that value is, whether the difference is significantly statistically significant or not.
Sir, here, how did we conclude, sir? Why the significance value is 0.956? This is what we are seeing.
No. See, this is a height is that the correlated value. So what is the correlation between the height and weight? That value is a 0.956.
Okay.
0.956. That means highly correlated. If one variable is increases, other variable is also increases.
Mhm.
Yes or no? Okay.
Yes, sir.
Therefore, in the previous example, the 80 is the height. The weight is also increases.
Yes, sir.
If the height is increases, weight is decreases. So this value may be just something different.
Mhm.
Okay. So I'm discussing significant values in the later on cases. Okay. Is it okay?
Yes, sir.
So if you go for the significant value and all these things, so one can go for NO table. That I'm going to discuss tomorrow. Okay. The once I completed, see that this one table is there. Okay. This table, NO. Okay. Regression schedule is there. Okay. This degree of freedom is there. F value is there. This value is this. Tomorrow I'm going to discuss about NO. During that one, I'm going to discuss these things. But here is you have to find out the coefficient values from this model is this. Okay. See, suppose if you are interested, you can go for the reverse way. Let us see that what will happen. May I check it? See that. See that I want to remove this one. I want to remove this one. Okay. So regression, linear. So dependent variable, the weight is there. So I want to make it height. Okay. So reset is there. It's okay now? No? Hello? Yes. I want to change this one. Interchange. Okay.
Yes, sir.
See that. Now tell me the A value is a 70.9. So consider 71 plus the 0.074 and the weight is 174. Am I right? If you multiply this, what would be the answer for that? Anyone helping to me? 0.074 into 174 plus 71. It comes to 83. Am I right? Yes or no? Hello? The point is clear? I'm not getting any answer from anybody.
Sir, yes, sir.
Because actually earlier we got 80 and here is a 174. Okay. So I consider 174 and estimate the value of height. Yes, that value is comes to 83. The slight difference.
So what will alpha be in this case?
Where it is alpha?
A plus bx. So in this case, what will A be?
See, a plus bx. A is a constant. B is the coefficient of height.
Yes.
So, yes, sir. So, it's 71, and the coefficient of x is 0.074 and weight is 174.
Okay, got it, sir.
Yes. In the previous cases, what you did, you know the height, you are going to estimate the weight. Yes. So at the time you got the answer is 174. Yes. Now by knowing the 174 and estimate the value of height, I'm expecting the answer exactly 80, but the slight difference is there. It is acceptable, 83. So basically the regression is for one linear regression for estimating the unknown quantities with help of the known quantities. Okay, the correlation to establish the relationship between the two variables. If there is no relationship, so we cannot estimate. So one must remember this point. Any doubt in this case? Any question? So everything is I mentioned that one. Go to the SPSS, open file, analysis, correlation coefficient, then bivariate, transfer the required variable to the test variable X, the select the mean standard deviation in options. Okay. Yes or no?
Yes, sir.
Okay. Any doubt? Okay. Move to the next one. If any questions are there, please ask me. No problem for that. Before starting the next point.
Sir, one small
Okay.
question.
Okay, no problem. Yes.
While predicting a plus bx, here in the first case we have taken height as x and weight as y. In the second case we have taken weight as y.
window
And
sir
height
है
as-
क्या?
सामने होंगे मिल लो.
So sir, my question is the coefficients that we get, from that coefficients we have found out the value of b. What will the value of a or the constant be in the case? In both the cases, first case and second case.
See it the simple way. I'm not going to create any confusion in your mind. Okay. Our
Yes.
equation is y is equal to a plus bx for single variable. Yes. Agree?
Yes, sir.
There are two constants. The one is a and b.
Yes.
Okay. You are estimating unknown quantity with help of known quantity. Agree?
Yes.
If x is known,
Yeah.
we want to calculate value of a and b by using the software.
Yes.
Simple.
Okay.
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 The simple one is that. I hope this point is clear.
Yes, sir.
So any value, either you can go for x or y. One time, so what he did, the first time I assumed that the height is 80 and estimated the value of point. The second time, assumed the weight and estimate the height.
Okay.
End out.
No, sir.
So okay.
Sir, can you show the variable view in this?
Once again,
Just the
I didn't
variable
save,
view.
I didn't save it. Otherwise, I can go for once again.
No, sir,
This-
variable view. Sir, the other view. Just the
Variable view.
Yeah, yeah.
Variable view. Yes, sir.
Okay, right. Sir.
I think yesterday I saved this data also.
Yes, yes.
Okay. Simple one is that. See, now I wanted to use t-test. I'm not going to explain about the inference factor. You know that null hypothesis, alternative hypothesis. I hope you know that all these things.
Yes, sir.
Okay, I'm not going to repeat all these things. I have to come to the point. So, t-test is there. T-test. T-test. You heard the name t-test? You heard the name t-test?
Yes, yes, sir. T-test.
Why you are using that t-test? Why are you using? To determine the significant difference between the two set of scores. That is, It may be one sample, independent group, or repeated measures. So whenever you want to apply the t-test, there are some basic assumptions are there. The first assumption is scale of measurement. The scale of measurement, it should be interval or ratio. Second point, random sampling means data should be randomly sampled. The third point is population normality. Means data is numerical representing samples from normally distributed population. Based on these three assumptions, we are going to apply t-test for one sample or independent samples or repeated. Okay. Now, the letters I want to take the one examples over here. Already I saved data, Excel sheet. Everyone knows this data? Yes or no? Hello?
No, sir, not this one. The quiz one data we had got.
No. Today morning I posted to Amul sir. Today only in the morning.
No, sir, not this data. We got the yesterday's data, quiz data that you did yesterday.
Yesterday's.
Quiz 1, 2, 3, 4, 5. We have got this one.
Just 1 minute. Okay, just to see that. The problem is it visible my screen?
Yes, sir.
Which
Screen is visible.
Yeah. See that the problem is like that. Indian Oil has developed a formulation with increased use of ethanol petroleum product, which increase engine efficiency with less harmful emissions. 30 cars were test driven with and without ethanol, and number of kilometers per liter were recorded. The car used for the test were having either automatic or manual transmissions. Car number 1 automatic, number 2 manual. The earlier trial shows that mean number of kilometer per liter was 12. Indian Oil wants to know, first question is, second trial efficiency of car is better than the previous trial. Second, whether efficiency of engine improves with added ethanol. That is a repeated T test. Third point, whether efficiency of engine with and without the ethanol differ between manual and automatic independent group of T test. I hope you understood this problem.
Yes, sir.
So today I'm going to share this also, no problem for that. That is not a big issue. So here is, if you want, you can type it, the car with ethanol, without ethanol. This is memory. Label is a car. Here is values. I want to define. Just 1 minute. Just 1 minute. So here is
So you can share this file with us also so that we can do it simultaneously.
so the please ask to the search. Already I said that the files. Please see that.
I think the notes are
Please check
Hello,
it.
sir.
Sir.
Hello, sir.
Today morning I
I don't get this file, sir.
No. Today WhatsApp, sir. Today around about 10 o'clock, sir.
Sir, no, I am
10
not
o'clock.
received. Can you again send me?
Just 1 minute.
Yesterday you sent only 3 files.
No. Today morning, sir. Today morning.
No, sir. I don't get any files.
No, just one. Correct. Just 1 minute, sir. Wait कर सकता sir 2 minute में.
Yes, sir. No problem, sir.
Yeah. Just 1 minute, yes, sir.
Yes, sir. No issue.
Sir, can it be sent on chat box? Is it possible?
Ma'am, I will send on our group.
Okay.
Please wait 2 minutes, sir.
Please check it, sir. Got it, sir?
Yes, I got 3 files, sir.
3 files, sir.
Yes,
The
sir.
one is
Thank
the
you.
one is the coding is there, and the second one is the Word file is that one, sir. That
Yes,
is
sir.
description of the problem, and the third one is the Excel is there.
Yes, sir.
Okay. If you open the Excel file, sir, you are getting the data as well as the data view and the variable view. Yes.
All three files I'll send in our group.
Okay, no problem, sir.
Okay.
आप इसको कितने में?
Balance is
I think 5,000 rupees something balance है.
उसको डॉक्यूमेंट्स चाहिए
तो payment कैसे 5,000 payment क्या आपको बताया?
बुक देने के लिए रेडी नया बुक पर नया बुक
कभी देने वाला?
अभी 5-5:30 बजे तक कुछ बुक देंगे तो मैंने उसको मंडे को बोला
मंडे को. Okay.
Okay, sir.
So this is the beauty of transferring Excel sheet into the SPSS. Directly you can get the data. Yes. Otherwise, you have to enter in data view. It will take more time and very tedious job. So that is why always prepare, create the Excel sheet. Thereafter we can transfer to SPSS. So here is the car is there. In car, there are two things are there: variables, value. The one automatic. Okay, add. Number 2, manual. Is okay. This is scale. So I don't want to change anything in here. Okay. This is also scale. It's okay.
Sir, how do
It
we
is-
import the file Excel from?
We go to the file, import. Okay. Import Excel. Is it clear?
Sir, I'm not getting this option in this.
First of all, to open SPSS package file. Into the center. Ready. Got it or no, madam? Hello? Got it or no? Is it okay?
Okay, sir. No problem.
Yes. Now, I'm taking only one sample. Okay. So,
ନାଇଁ ଏବେ ପଢା ହେଇନି ସାର୍। ଆଉ ଆଗତୁରା ତ ଯାହା ତ ପିଲା ପଣ୍ଡିତ ତ ଆଗତୁରା ପଠେଇ ଦେଲେ ସେ ତ ଆଉ ଆସିବେ କ୍ଲାସକୁ।
we want to know
ଆଗତୁରା ପଠାପଠି
whether,
ଏବେ କଣ
whether mean of the population from which the sample is drawn is the same as hypothesized mean. Okay. So here is analyze, compare mean, one sample test is there. All of you got it? So you are getting this window. Here is my test variable is with ethanol, and the test value is there. This test value is in the problems is there. Look here. The earlier trial shows that mean number of kilometer per liter was 12. It is given in the problems. Okay. If you press OK, you are getting this window. This is one sample statistic. With ethanol, N is a 30, mean is 16.60, standard deviation is 5.48, and standard error is 1.001. All of you got it on this number?
Yes, sir, got it.
Yes, sir.
Okay.
Sir,
Now, yeah. Which one? Which step?
This step,
Which?
sir.
See, this is analyze. Go to compare means. Here is a one sample test. Okay. I selected with ethanol. Test value given in the problems. So there I consider 12. Okay. So this is the output result. All of you got it?
Yes, sir. Got it.
So now you can listen carefully. The interpretation of these values. This is a t value. The t value is a 4.597. So this is a degree of freedom 29. How it comes 29? Anybody? Any idea? So the degree of freedom is n
minus 1.
N minus 1. So here is n is a 30. So minus 1 is a 29 degree of freedom. Okay. The two tail values 0.00. It is a significant. It is significant. So that means this value is a less than 0.05. The difference between mean is significant. So this output indicates that there is a significant difference in engine efficiency between previous and current trial. So the car is current trial have more engine efficiency than those in earlier trial. So key value, degree of freedom is a 29 and this value is a 4.597. So P is less than 0.05. Is it clear or no? Clear?
Yes, sir.
Okay. Now, so do you want one more example on this one?
Yes, sir.
Yes, sir.
So can you please show the variable view? I just got it open now only. What changes have you made in the labeling, sir? Values. One is for
Automotive. One
in
is
the
one is
car variable you have put, sir.
see that
Okay.
automatic. One is automatic and two is a manual. Got it, madam? Is okay? Is it okay?
Yes, sir. So please do one more example.
One more example, just 1 minute. Instead of giving the different one, the same test instead of see that you open height, weight, and this one. Okay. This. Analyze. Compare mean. One sample test. Okay. I'm taking only one variable, height. Okay. So here is that is mean is 66 is there. I'm going to consider 67. 67. Okay. You got this value or something different? Anybody? Hello? This value is not a significant 0.290 because population mean is 67, but the sample mean is comes to 60.6. Lot of difference is there. Is it okay? Hello?
Yes, sir.
Yes, sir. Suppose if you want more accurate, so I want to change the data value. How to change the data value? Check it. See, this point is understood. The mean is a 16. I consider 67 is the population mean. The test value is 67. There are a lot of difference is there between this and this. Suppose if you want to more accurate, I want to increase the instead of 10, I want to increase the under 6 values. See, the please you can add some values over here. This is the 65, 60, 69, 73. So I want to increase the mean 69, 72, 68, 63. The please enter these values once again. 74, 70, 66, 64, 60, 67, 65. Because yesterday I entered the random values 150, 155, 160, again 160, 150, 140, 165, 150, 110, 100, 95, 110, 105, 100, 110, 105. Here is 1. Okay, all of you done this one? Hello?
Yes, sir.
Okay, I entered the 16. Now I want to apply one sample test to I enter the 67 is there. Let us see that. See that. All of you got it? Hello? Huh. Okay. No, there are specialized subjects. Yeah. Thank you. Sorry for that. See that. N is a 16. The mean is a 66 point something. The standard deviation is a 3.9. And the standard error is 0.983. So the one sample test height is the 0.123. The degree of freedom is a 15. The 16 minus 115. So this is the 0.990 is comes. Okay. The mean is this much. Here is what happens. The upper limit and the lower limit is given. 95% confidence interval of the difference. This. So this indicates that P value is the 0.127 with a 15 degree of freedom and the significance level of 0.95. The mean difference of 0.125 is the difference between sample average 66.88 and population average is 67. Okay. See that population mean is 67 and sample mean is 66.88. What is meaning of this? That indicates that sample mean is not equivalent to the population mean. That means significantly different. That means there is not a significant difference between the means. It does not mean that they are equal. Okay. Anybody's? The sample mean and population mean are not equal. Any confusion? Okay. Hello. May I close this one? Hello. Hello. I'm not getting any voice.
Yes, sir.
So I can come back to the our major problem is I used with ethanol and without ethanol is there. Okay, one sample test.
Sir, please read the chat box. Some participants are replying our chat box, sir. Sir, this is a not chat box.
Is correct. There is no, because sample mean is 66.88 and second one is the population mean is 67 is that. This is correct. The value of the T came out to this one, so which is not a significant level. It will be concluded that the mean score of the height of the population and the sample is not a 50%.
Sukraj,
So
can you
Sukraj
answer?
Singh.
Sukraj Singh?
It's correct. What I told the same thing is that. See, the single sample test is simple thing is that one. Say, for example, suppose the weight of the bag, cement bag, whatever that one, the 100 kg. It is the population mean is 100 kg of the sugar bag. If you pick up the 10 bags as a sample and start the weighing, the mean may be 98 or 99. Or maybe 101 or 102. Our hypothesis is mu equal to mu naught. Alternate hypothesis is a mu is equal to mu not equal to mu 1. If you read that the one sample test, student T test, hypothesis is the population mean is equal to sample mean. I hope Sukraj Singh is the point is clear. Hello. Okay, no problem. Anybody? Is correct. Okay. So may I continue for that? Hello.
Yes, sir. Continue this session. If you want to take a break, so give the 10 minutes break of tea break.
You want 10 minutes, sir? No problem. So exactly we will start. Now it is a 4:30, sir? 4:30.
4:40.
4:40. Okay, sir.
Okay. So now it is a tea break in
Okay,
10
no problem.
minutes.
Yes, yes.
So session will be start on 4:40.
Yes.
Hello, Kanchan ma'am. Any doubt? Kanchan ma'am. Hello, Kanchan ma'am.
Sir,
Yes, ma'am.
सब खुश हो गए बच्चे, हाँ? सब खुश हो गए बच्चे। कितने? अच्छा, ऑफिस। तो लिखित भी बोला तो नहीं। मैं मेरे पर कई 5 मिनट 10 मिनट इसलिए तो कितने स्टूडेंट ऑप्शन थे? एक बार ठीक से लिखो ऑप्शन क्या है तो मेरे को लिखो, बराबर? मैं इसको व्हाट्सएप कर कल इसका लाइनअप करता हूँ। हेलो। Shall we start?
Yes, sir. Start session.
Okay. Welcome after the break. So now the thing is that I'm going to discuss the one more sample T test that is called paired T test. Paired T test means the pair of two. Suppose, for example, mother and daughter. This is also one pair. Husband and wife. This is also one pair. So in this case, one is dependent on other factors. Here, the dependency between the two observations is taken into account. And each set of observations serve as its own control. So for example, if you conduct an experiment, the effect of presence of others on problem solving performance. Presence of other on problem solving performance.
Sir,
Here,
your
voice
hello,
is
sir.
not
Voice is clear. Sir, voice
Yeah.
is clear, but your presentation, where is your slide? Means, are you open
Okay.
only SPSS, sir? Your PowerPoint
Okay.
presentation not visible.
So now I want to share it. Okay. Is it clear? I hope you can see. You can see
Yes,
the my.
Yes, sir. Is it visible?
See, in this case, whether the efficiency of the engine improves with added ethanol, repeat the measures T test. Okay. So now I want to check this one. Second options. In this second options, I'm using T test. Okay. So what to do? Analyze, compare mean, paired sample T test. You are getting this window. In that one, the pair is with ethanol and without ethanol. All of you got it, this one? Then okay. See, this is my output. Paired sample statistics. The pair one with ethanol, without ethanol. Okay. Mean is 16.60. Then 15.167. All of you got it out this point, this output? All of you got it out? Yes, please, audience.
Yes, sir.
Got it result? Same result or something different? The standard deviation is a 5.481, then 4.3891. Okay. And with ethanol and without ethanol, then it's 30. Correlation is a 0.934. So I have to subtract it. Type it all this in separate. .934. Okay. Now this is my paired difference system. The mean is 1.44. Standard deviation is 2 point something, and standard error is 0.3819 something. Low value. Upper limit. T value is 3.753. This is the degree of freedom is 29, and significant value is 0.001. All of you got this one? Yes. So what does it indicate this value? This output. The value of 210 significance is less than 0.05. Agree? Yes or no?
Yes, sir.
As such that the difference between mean is significant. This output indicates that there is a significant difference in engine efficiency between without ethanol and with ethanol trial. So the car with ethanol additive have more engine efficiency than those without ethanol. T is 29. 29 is correct? No, 29 degree of freedom, and the T is 3.753. The P is less than 0.05. Is it clear? So this is the answer for the second question. Efficiency of engine is improved by added ethanol. Is it clear?
So the answer is that it is efficient since it is 0.001, which is less than 0.05.
Yes, it is significant.
And so that means it makes a difference adding ethanol, right?
Yes. Okay. The engine efficiency, significant difference in engine efficiency between without ethanol and with ethanol. Okay. So do you want one more example like that? If you're not understanding automobile sector, I want to take a different one. Is it okay?
Yes, sir.
You want one more example?
No, sir.
Yes, sir. It would be nice if we have one more example.
One more example. Okay. I want to take a very simple one. Yes. I don't want to create any much data. The two values are there. Okay. The two values means the variable u. Okay. The variable u is participant. It's simple. Okay. Participant. Numerical. Okay. First. Okay. Next. Alone. Memory. And other. Now, this participant to write it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I want round figure instead of decimal point to make it 0. Data alone 12. I'm going to explain it. Just enter 4, 6, 12, 11, 12, 7, 12, 9, 5. This also I need to close this. This is 0. This is 0. Other is 10, 6, 5, 5, 10, 5, 7, 7, 3, 6, 7, 8, 2. See, all of you done it? Is it clear?
Yes, sir.
Now, see that. Here is the two variables are there. The one is alone and second one is a others. So that means higher score indicate better problem solving performance. The one is the presence of others. Presence of others means others is variable. Problem solving performance dependent variable. See, participant 1 अगर alone होता problem solving performance is good in presence of others. Here is 8, 6, 4, 5, 6, 5, 10, sorry, 12, 10. This is the thing is that. So here, how to perform these two things? One is the independent variable and other one is dependent variables. Dependent variable, problem solving performance. Independent, presence of others. How he is going to take the decision? Definitely I am going to apply pair T test. Here, analyze, compare means pair T test. We got this one? Yes or no? Now, variable 1 and variable 2 alone and second one is a other. Okay? Okay. So this is the output. Output is alone is comes 8.08, other is comes 6.7. Number of observations 12. The standard deviation is 3.09, 3.029. Standard deviation is 2.443, and standard error mean this much. Then pair and sample correlation is significant. That correlation R value is 0.858. So is it clear? Paired sample correlation. Anybody? Mean is this one, standard deviation. T, degree freedom level. This is significant. I hope understood this. Hello. May I continue with the last step? Any questions on this part?
No, sir. Thank you. Thank you.
Okay. So in this way, you can analyze the things where T test. Okay. So here is what happens in other type of examples. Students are there.
Sir, Chandrasekhar has doubt, sir.
Let us. I want to see in chat box. Okay,
He
please.
raised the hand.
Yeah, please, sir. Okay.
Chandrasekhar,
Chandrasekhar.
any doubt? Any doubt?
No, sir.
Okay, ठीक है.
So
Go ahead.
usually in the pair T test is like that. A simple example, all are in the academic layer. The student scoring with the tuition, without tuition classes. One student is depends on college, other student is depends on tuition classes. Is there a significant difference between the taking the tuition classes and without taking tuitions? So this kind of examples are always carrying the pair T test. The one is a dependent, other is a independent. Just 1 minute. Yes. Okay. Chandrasekhar, no problem. See, now independent group is there. The same problems, same database I'm using for independent people. Here, so when this test is appropriate, when a different respondent have performed in each of the different conditions, can say that respondent in one condition are different from respondents in other condition. Usually referred it as between subject. So what are the assumptions here? Independence of group. Respondent should appear in only one group, and these groups should be unrelated. The second condition is that homogeneity of variance. Variance of groups should be similar. That I'm going to show in the tables. Okay? That is not a big problem. I'll show that. So here is go to analyze, compare, independent sample t test. Okay. So the test group is there. The two variables are test variable. Okay. Count. Okay. See that little bit. This. Compare with independent sample test. The two variables are test as well with ethanol, without ethanol. Like the two variables are one and two. Okay. So this is my. Okay. All of you got it? This one? Something different. Anybody? Hello? All of you got it, this output?
No, sir.
No?
No, sir.
See that. Once again, I'm performing that one. Please see that. See that. This is my database. Yes or no?
Yes, sir.
So how many observations are there?
Hmm.
30.
Yes,
The
sir.
last one is 28 and 20. Okay.
Yes.
How to perform the independent sample test? Go to analyze. Compare means. Independent sample test. Up to this point is okay?
Yes.
Yes, sir.
Okay. So, see, actually, it is like this. Okay. It is like that. Two independent variable. One is with ethanol. Second, without ethanol. And a grouping variable. This I want to define group 1 and group 2. Continue. All of you got it?
Yes, sir.
Okay. Now, okay. Got it? This output?
Yes, sir. Got it. Thank you, sir.
Yeah.
Yes, sir.
So the first one is automatic and manual. Without ethanol, with ethanol. These numbers are correct. These are correct. See. Now the question is comes over here. I want to enlarge this one. This is the most important part. Equal variance not assumed. The one is with ethanol, second is without ethanol. See.
Oh my God.
Point.
All participants, please mute your mic.
Yeah, please proceed. 8, 9, 10, 40. Significant value 0 square. Look, I'm interpreting these values without ethanol. F value is full variance is there. Therefore, F test is there. So significant value is a 0.059. Okay, 30 is a 28. This is this. C. Without ethanol shows probability is the greater than 0.05. That is 0.059. Am I right? Yes or no? This probability is greater than 0.05. Yes. We assume that population variance are relatively equal. Relatively equal. One can use p-value, degree of freedom, and two-tail significance. When this value is greater than 0.50, you apply the p-value. What's the p-values? Two-tail significance for equal variance estimate. So whether the car type difference exists or not. The two-tail significance for a two-tail yes. That P is greater than 0.05. Therefore, it is not significant. One can say that the two groups comes from same population since no significant difference exists. That is T 4.468 28 and this. The P is greater than 0.05. So this can be quoted null hypothesis. That is, no significant difference exists in car type in case of without ethanol addition. The null hypothesis is no significant difference exists in car type in case of without ethanol. Without ethanol. In second case is with ethanol. Interpretation is probability is greater than 0.05, that is 0.665. See that 0.668. You can assume that population variance are relatively equal. Use a T value, degree of freedom, two-tail significance for equal variance estimate to determine whether car type difference exists or not. The two-tail significance for with ethanol shows P value is greater than 0.05. Yes or no? 0.66605 and is not significant. This means the two groups comes from same population. Since no significant difference exists, P value is 5.213. P is greater than 0.05. This means null hypothesis, no significant difference exists in car type in case of ethanol addition. So I hope you understood the interpretation of this one. Any doubt? Is it correct? There are three options are available in a T test. The one is one sample test. Second is the pair or dependent test. Third one is independent group T test. So all these options are available. Just one minute. Available for this one. You can apply the same example for the one sample test, pair T test, as well as the independent test. So earlier I took this example. Is it possible to take it? Independent test for this? Yes. See, here is the variance is equal variance is assumed equal variance is not achieved. In statistically, we can say that null hypothesis mu1 equal to mu2. Alternate hypothesis is mu1 not equal to mu2. Mu means the population mean. Population mean of the first group equal to population mean of second group. This is null hypothesis. Suppose if you want one more example, I can explain it. No problem for that. See, the simple example I want to take it. This is a variable type. Take a number. This number is so yes and okay. The serial number is the numeric. Okay. Yes. This is number. Second is gender. Gender label. One male and two female and okay. So here is I define P. P. Female.
class.
Just one. Just one. So here is label. What I'm going to write it. Sales in previous month. Okay. This is the previous. Okay. 1 minute. Fine. Seven, 8, 9. It's okay. How to remove this one? Clear. The gender is there. Randomly I can select it. 1, 2, 1, 2, 1, 1, 2, 2. This is 75, 90, 94, 95, 100, 90. Sorry. This is 70. 62. All of you copied it? Please prepare the data sheet in this way.
सीडी का लेक्चर होगा
ठीक है, ठीक है।
होगा तो
मैं आपको बता, मैं तो आने वाला है कल 11 o'clock, और आप आता है साथ देखूंगा, 1 घंटा लेकर आपको है कि नहीं?
हाँ, बुक्स अभिषेक सर ने दिए थे।
दिया। So here is there are 8 sales persons are there, selecting at random. That salesperson consists of both males and females, and their sales figure for the previous month, like that. What to examine that? Average sales of males and females is same or different in the previous month. My question is clear. What we are going to test? The average sales of males and females is same or different. Okay. The sales performance is independent, both groups, male and females. Agree? How to do this one? Go to analyze. Compare the means. Independent sample test. So, test variable is sales and gender is grouping. Define 1, 2. Okay. All of you got this number? Any question? Hello?
Sir, just tell the interpretation part.
Yes, yes. That is why I'm asking that. The first person is, sorry. So, little bit I want to change randomly I have to take. Let us see.
Hello, sir.
1 minute, 1 minute.
Okay, okay, sir.
Just 1 minute. Just I change the gender. First 1 1, 2 2 2, and 1 1 1. Let us. I want to see the changes. Okay, no problem. Yes. The males are 5 and females are 3. Yes. Interpretation form. All of you got this number? That this result or something different?
Hello,
If
sir.
say, okay, sir.
Sir, I have a question.
Yeah.
Hello, sir. Sir, how can we
Sir.
define how can we define how many males and females in second column?
Sir, this is my assumption. The male and female.
Okay. Okay, sir. Okay, okay.
So there is no any hard and fast rule. This is the data.
Okay, sir.
Okay. So the total is for simple understanding. I make it 8 participant. Out of that, 5 is a female and 3 is the males, like that. Okay. So these are my numbers. random numbers. Okay. Is it clear? Hello?
Okay, sir.
Yeah. So the sales in the previous month male is 5. Their mean is 77.80. Sales in the previous month female number is 3. Their mean is 96.32. Okay. So the standard deviation is 11 and female standard deviation is 3. So who are the good performance in the sales? Which group is perform well?
Females.
Very good. Because average is more and the standard deviation is less. Okay. So what is your question? The average sales of the males and females is the same or different in the previous month. Okay. Therefore, we selected this. The one is equal variance assumed. Second is equal variance not assumed. Okay. So degree of freedom is a 6. E value is a 2.587. And this is a 0.041. Okay. This is a 0.06. See that. If the significance value for the test is high, typically greater than 0.05, then use the result that assume equal variance for the both group. If the significance value for the test is low, less than 0.05, then use the result that no assumption that we do no assumption equal variance for the groups. Low significance value for a t test less than 0.05 indicate there is significant difference between two group mean. So p value is 0.002, which is less than 0.05. Therefore, null hypothesis is rejected. We can conclude that there is a significant difference in the previous month sales by the males and females.
Sir, while reporting, we have to take which p-value, equal variances or equal variances not assumed while writing? Which one should be taken?
See that here is the two options are there, two values are there. The one is high value. The t test is a high. That means the greater than 0.05. Greater than 0.5. In that cases, you assume that equal variance. Equal variance.
So please repeat.
The significance value for the test is a high, typically greater than 0.05. The result assume equal variance for both groups. If it is less, no assume equal variance. In here is the two options are available: equal variance assumed, equal variance not assumed. Okay, so I hope the point is clear.
Sir, in both cases, it is less than 0.05. So, which value should we report? 0.04 or 0.02?
0.04 and 0.0, both are less than this one. So that means consider as a no assumption, no equal variance. Second point. This is
Normally,
equal
sir,
variance.
equal variance is not assumed.
Yeah. Equal variance not assumed. Okay.
Okay, sir.
So therefore, I'm taking this value. The p value 0.02, which is less than 0.05. Therefore, null hypothesis is rejected. We can conclude that there is a significant difference in the previous month sales by the males and females. I hope the point is clear.
Yes.
Is it okay? Any questions? Do you want to take one homework? Can try it. Okay. Any questions? Anyone? So you can check, so first thing you can check the normality is also there. So I'm not going to this. So these are the simple things are the based on the assumptions. See, the F values comes because of this variance. You are going to check the equality of the variance. It's okay. Yes. Any questions? The system is calculating all these things, sir. You can't say anything about that one because theoretically something different, slight differences are there. So if you want data should be the normal, correct? So you can check it. Normality is also there. So hello. Hello. Ah, yes, Surendra Patrik. Hello. Surendra.
Surinder, no reply, sir. Please continue.
No, you raise the hand. Therefore, I'm asking the questions. So all these things needs the practice. The practice makes man perfect. We are using statistical packages. So if you think on the line of the theoretical part, mathematical part, and the software, the slight difference is there. Okay. If you go for the manually for calculation of all these things, it will take more than 1 hour, sir. But the software is supporting to us. The which value is a power to us, that you have to take it and interpret it in the proper place. So tomorrow my plan is maybe check it, sir. So even though if you are using the Excel also for this type of, in Excel, there is some test are there. Chi-square test is there, student T test is there. If I apply this one, so let us see that result, how it comes. But in a calculator, 2 plus 2 is equal to 4. If you use any calculator, the answer is a 4. But different people have developed the software in the different theory. Definitely we'll see that a little bit of difference is there as per my experience. So I'm going to continue tomorrow regarding that is one way ANOVA and some non-parametric test. Okay. If you want any other things, that is also good. R values is also there. So one can use R programming is also there. Good. So you can use Python also. Anybody? So today I covered the simple regressions, the correlations, then the student t-test. One sample test, independent test, and their t-test. I'm going to cover it with chi-square and other things in the non-parametric test. In all these things, if you know the basic assumptions of the each test and the procedure, and the third step is interpretation of outcome. So this much is sufficient for writing the good thesis. Okay. Okay, someone is see that. So here is regression is then estimate. Suppose this is height and weight instead of height and weight. So if we consider the year and this is the sales, we can estimate the production of the any year. One can use the regression. Because there are regressions. I covered only the most common things, linear regressions. Non-linear is also there. Multivariable regression is there. Partial least square. So these are a little bit advanced and not using frequently. So anyone can use these things. So now I want to remove this one. Suppose 2000, 2001, most of students are came from the economics background. In economics, we are using estimate value or costing value with a different one. Six. 7, 8. See that. I want to remove this one. Okay. So I want to estimate the sales, what will be that? Don't consider this height and weight. So these are the year and these are the productions. What would be the production in the year 2011 by using this previous figure? So go to this regression. Linear. So we can define year is 2019. So height is the dependent. Wait. See, this is the constant of y is equal to a plus bx. We can use these two constants and estimate the production for the year 2011. In the classes, we are going to explain about y is equal to a plus bx. Y is equal to a plus bx. Okay. Any questions, sir? Hello? Hello? Hello?
Yes, sir.
So, if any questions are there, I'm ready to discuss. If no questions are there, I want to finish this session. Anybody? Any questions?
Surendra sir. Surendra sir, any question?
No, sir.
Okay. So please, if you know the any other software, that also you can see that the same data for in other software how it works. Okay, I'm not going to discuss other softwares over here. This is specifically for SPSS. Okay. If the small quantity data are there, one can use the advanced Excel is there. That is 2019. The work in the Excel is there. That is also almost on 50 to 60% work complete done. Okay, with using the statistical packages. If the huge quantities are there, then only we can use.
Sir, please stop your sharing.
SPSS. SPSS. Okay.
Any doubts, participations in this session? कोई अगर प्रॉब्लम है या कोई समस्या है अगर आपको रिगार्डिंग दिस सेशन आप सर से बात कर सकते हैं.
So how to print the calculation of SPSS? So here is the output. You can select it and put in the word. Okay. That's the one option is there. That also you can do. The option is there. Print preview and print this. Okay. One can use these two options. So usually crop and all these things. Save in the .doc and to take the printout on the papers. But the statistical statements are there. That much you can select it and do it and take the printout. So all are using a trial version SPSS.
How many person are downloaded trial version in SPSS? Means today's your assignment is a practical assignment. Sir are given the some Excel sheet. I forward this Excel sheet on our group, and please download your sheet in our Google form. Now in this session means is 2-3 sessions. It is a practical tech assignment. So please, if you any problems, if any doubts, so please ask the sir. Now I wind up this session.
Yeah. So another thing is, I agree for that. This is not so that much of easy, but depth knowledge is required for interpreting the values. So randomly you can't apply all these things. First of all, you must understand the assumptions under which circumstance. So this test is applicable, and properly we have to define the measures. Okay. Thereafter, apply the statistical test. So
Actually, sir, basically, some participation asked me this question:
yeah.
how to be connected with the SPSS in our data and our PhD title. Can you interpret this question?
See, the data is important. Okay. What type of data, how we are collected. So what purpose you are doing all these things? Say, for example, this data is there. Suppose everyone is just attending the data. Okay. So before joining this workshop, what about their research knowledge or analysis knowledge? We can apply the PRT test. Performance of research analysis level. Before training, after training. You can go for scale 1, 2, 3, 4, 5. Neutral, good,
yes,
better, or some points 1, 2, 3, 4, 5. And see that this is also a good exercise for you.
Okay, sir.
Whether this session is useful or not. By attending whether attending the 10 days, what is my understanding level regarding the research work? So in the near future, to attend the seminar, is it good or bad?
It's very good, sir.
Yeah, you can apply all these things.
बेसिकली सर ऐसे प्रॉब्लम्स बहुत सारे होते हैं कि टाइटल सबमिट करने के बाद, मतलब जब टाइटल हम लोग फ्रेम करते हैं, टाइटल सबमिट करने के बाद जब डेटा कलेक्शन की बारी होती है, तब मोस्ट ऑफ द रिसर्चर आर सेंड इन लिंक टू द व्हाट्सएप ग्रुप, some third party, some person. They not collect the proper data, and some result are in mismatch. मतलब डेटा बहुत अलग से आता है, हाइपोथेसिस क्लियर नहीं होती है, हाइपोथेसिस को मैनिपुलेट करना पड़ता है, और इसके कारण क्या होता है कि हाइपोथेसिस को मैनिपुलेट करने के बाद डेटा कलेक्शन प्रॉपर नहीं हो पाता है और कंक्लूजन अलग होता है, और वो कंक्लूजन मैनिपुलेट करना पड़ते हैं, और उसके बाद में पीएचडी सिर्फ अवार्ड होती है. तो बेसिकली ये 10 डेज फैकल्टी डेवलपमेंट प्रोग्राम का यही रीजन था कि हमारे जो पार्टिसिपेंट्स है उनको ये मैनिपुलेट ना करना पड़े. एक्चुअली टाइटल है, जिस टाइटल बेस के ऊपर नॉर्मल तौर पे प्राइमरी डेटा कलेक्शन है और सेकेंडरी डेटा कलेक्शन है, हाउ टू यूज इन SPSS इन सेकेंडरी डेटा कलेक्शन एंड हाउ टू SPSS यूज इन प्राइमरी डेटा कलेक्शन. बेसिकली ये अंडरस्टैंड हमारे पार्टिसिपेशन को नहीं हो रहा है. तो बहुत सारे पार्टिसिपेशन बोल रहे हैं सर थोड़ा सा समझ में नहीं आ रहा है, डिफिकल्ट थोड़ा सा लग रहा है. बेसिकली उनको टी टेस्ट के बारे में थोड़ा सा अजम्पशंस कम है, रिग्रेशन के बारे में थोड़े से प्रॉब्लम्स हो रहे हैं, और प्रैक्टिकल सेशन ना होने के कारण मींस प्रैक्टिकल असाइनमेंट ना होने के कारण उनको प्रॉब्लम्स हो रही है। तो मेरी रिक्वेस्ट है आपको, एक हम्बल रिक्वेस्ट, थोड़े प्रैक्टिकल सेशन दीजिए। कल संडे है तो कल थोड़ा सा फ्री टाइम है, तो मैं गूगल फॉर्म के थ्रू असाइनमेंट क्लियर करता हूँ और हमारी पार्टिसिपेशन को और ज्यादा एसपीएसएस समझ में आए, और ताकि उनके पीएचडी में आपकी नॉलेज हो जो उनको हेल्प करे, ताकि बेटर अजम्पशंस हो, हाइपोथेसिस प्रूव हो और उनका कंक्लूजन प्रॉपर निकल के आए।
For all your questions, I'm going to say in one sentence: analysis, interpretation, manipulation, all these things. Because of bad collection of data. So everyone is thinking after collected the data analysis, अरे ऐसा नहीं होने के थे, ऐसा होने के थे. So what is your objectives? How to train the questionnaires? What are the things I want to include? The Google form में आप forward करता, you are collecting the informations. That tell to me how many people are entered the correct data in the Google form. What is your mental status? What is their understanding level about the subject? A नहीं तो B, B नहीं तो C. Randomly they are putting it. The primary data, face to face you collect it. Then understand is the person's understanding level, education. ये मेरा क्लोज फ्रेंड है, गूगल फॉर्म भेजा था, उसको अप्लाई करो. Yes sir, no sir?
Yes sir.
The secondary data आप use करता, अब secondary data from which sources you collected, how they collected the data.
Mail.
This is the one of the basic things, sir. Suppose
email and journal books. They that.
Okay.
Okay sir.
So suppose if we see that the TV channels, there are so many channels are predicting the number of seats, X party, Y party, C party. If you select the 5 channels for 2024 election result, the answer is same. The number of seats are same. The why you are observing the variance? The way of collecting the data, how much area they are collected, whether it is a rural area, semi-urban area. What is the literacy rate of in that area? In that area, person is important or party is important or both are important. So it is very difficult to predict. The way you are collecting the data, that itself is a reflect for the result.
Yes sir.
This is the point is that. So suppose in this example, today I took almost all 2 to 3 to 4 examples on every aspect, the regression equations, t-test. In the regressions, the one is a dependent variable and one is a independent variable. This is the equation is y is equal to a plus bx. So which value you are going to estimate by knowing the other values. So in the output, the coefficient value you have to pick up. Before that, the accuracy of the estimation or prediction, based on the correlation. If the both variables are highly correlated, then definitely your estimated value will be more or less near to the actual values. If the correlation is very, very negative and estimated some values, I'm not going to say anything about that, whether it is right or wrong to the actual value. So for all these things, the data is the most important.
Yes, sir. Sir, Satish Gokatekar. Satish, sir.
Sir, I have a question.
Yes, sir.
Sir, in my PC already installed IBM SPSS 16. It's the same our stations SPSS and my PC is SPSS.
Okay. Which version, sir?
IBM SPSS 16.
16. Okay, that is so too old, sir. 16. So now it is a 25, 26 is running. Sir.
Okay.
Yeah.
So not useful?
No, I can't say that like that one. I can't say that one. Useful or not useful. So
again,
the latest versions are always better, sir.
Sir, today's session very difficult. So could you please share your recorded video, today's recorded video?
Yes, sir. Yes, sir. Definitely, I will send you on our group because of so much GB in the videos. So I will upload in YouTube channels, and then I will send you today itself. Because of Google Meet, or download this session, and after I am download this session and uploaded this session, this take a time, take a 2 hours time, sir. Yes, Usha ma'am, if any doubts and any. Hello, Usha ma'am. Hello. Yes, sir. Satish, sir, please.
Sir, can you suggest a book to refer for SPSS for further reading, which you recommend as we students we should follow?
So by reading the SPSS, you can't understand this concept. First of all, understanding the statistic is important. Say, for example, I use the student t-test for the single test. The hypothesis is mu1 is equal to mu2. Sample mean is equal to population mean. ये टेस्ट करने के चाहिए. से फॉर एग्जांपल आपका एक मशीन साइज, एक मशीन वेव करता एक पर्टिकुलर प्रोडक्ट से फॉर 100 kg. Okay, अब 100 kg whether the machine is waving correctly or not, how are you going to test it?
Statistical.
हाँ, एक्स कंपनी आप सेट करता, आप कभी भी कोई भी रखो, इसका वेट कितना हो सकता है 100 kg होता है. ओके, 100 kg. बाद में तो आप प्रैक्टिस करने के शुरू में एक बार आप 110 होता, एक बार 98 होता. ये सेटिंग ठीक नहीं हो सकता. इसका मतलब कंपनी का सेटिंग बराबर है कि नहीं. Therefore, you are taking the sample of 10 or 15 at a different interval and calculate it, sample mean weight. If it comes 99, if it comes 105, that means what the setting is same to the population, sample mean? No. आप कंपनी में जाकर आपका मशीन is not working properly. This is our subject, statistics, t-test, single sample test. जो भी पॉपुलेशन ऑफ सेट करता है, इसके सैंपल वैल्यू से हम टेस्टिंग करता है. So there are two things are there. One is the estimation and second one is the hypothesis in statistics. Hypothesis, I'm not going to discuss about the estimation. Estimation, the point estimation and interval estimation. In point interval estimation, always using the range. plus or minus left hand side and plus or minus right hand side. In hypothesis, actually you conduct the experiment and note down the result. So that result, how it is correlated to the population mean, population standard deviation. If it is accept, then it came from the same population. If reject, it came from the different population. So these are the important. By learning the statistics, you can understand the basic concept. Once you understood, thereafter one can use SPSS or R languages or any other softwares. This is a basic difference.
Any question, another participation? कोई question है, कोई doubt है? Yes, ma'am.
Arvind sir, the session was very informative. Relating to the output of the data, interpretation is very difficult, sir. Can you explain more while creating output, sir, in the next session? Because the interpretation part itself is difficult for us.
So the interpretation is a need a lot of knowledge is for understanding. Say I can say that the significant, not significant based on the values. The p value is less than 0.05 is significant. If it is greater than that, it's not a significant.
Okay. Sir,
say for another value is there.
Yes,
suppose R and R square. Tomorrow I'm going to explain it. Okay.
Yes. Sir, one more thing, sir. Relating to Excel sheet, if you share the data, whatever the work you do, that data, if it is shared previously itself, it would have been better to get do the same work, sir, with you. That is hands-on experience.
Okay. No problem.
Okay, sir. Thank you, sir.
If anyone, thank you, sir.
Okay.
Ladies and gentlemen, good evening to all. On behalf of Professor Ramkrishna More College, Arts and Science, it's my pleasure to thank you, sir. Take a wonderful session, and thank you to participation to join us our FD Faculty Development Program. Now, tomorrow, same time, same day, I will, sir, and I will meet you on regarding lecture of SPSS. So now I am conclude that in this session is wind up now today.
सर
Okay.
हेलो
Hello. Yes, sir.
कल संडे है तो ज्यादा लो ना, मतलब थोड़ा ज्यादा समझ में आएगा. तो थोड़ी डिफिकल्टी है समझने को SPSS.
No problem. I'm also Sunday free है सर. आपके लिए तो मैं फ्री है, कब तक स्पेयर करता, so मेरे को भी डिस्टर्ब नहीं हो सकता. Okay. Definitely, we'll take more examples and clear the concept.
Thank you, sir.
Okay, thank you everyone. Thank you so much.
Hello.
Hello, sir.
So what I'm going to ask you, you want more examples or to clear the concept?
I want more examples, sir. Means
Okay.
participation, better understanding.
Yes, sir.
Thank you, sir.
क्योंकि क्या होता है, हम जब आप देखते हैं तो स्क्रीन जब देखते हैं और इधर प्रैक्टिस जो करते हैं तो आगे निकल जाते हैं, तो